This video is going to introduce you to fossil fuels, what they are, how they're formed, and how we use them. So remember we talked about different carbon pools, and one of the biggest carbon pools in the entire planet is Earth's crust. Within Earth's crust, we have these things called fossil fuels. And I don't know the exact number of gigatons that are just for fossil fuels, but remember that the entire Earth's crust is over 100 million gigatons of carbon. So fossil fuels do play a huge role in the global carbon cycle. Now, what exactly are fossil fuels? They are mixtures of organic compounds that have very high energy carbon to carbon or carbon to hydrogen bonds. All right. Every single one of these is found underneath the Earth's surface, and we can extract them and use them nowadays. So, the three kinds of fossil fuels. There's a solid form, which we call coal. There's a liquid form, which we call petroleum, or you might hear it called oil, and the gaseous form, which we call natural gas. These were all formed over millions of years, pre-dinosaurs, from the remains of plants and animals. Let's take a closer look into petroleum and natural gas. Petroleum and natural gas were formed from the remains of animals and plants that lived, again, pre-dinosaur in a marine environment, which means we're talking about organisms that lived in the ocean. Now, those organisms died. They were covered by layers and layers and layers of sand and silt that compressed them with high amounts of heat and pressure, eventually transforming the organic molecules that were once in them to different organic molecules that helped to create ultimately petroleum and natural gas. So we can extract these now and use them for a variety of reasons. Normally you see, like for petroleum, you'll see like oil rigs, especially out in the ocean, as one way of extracting them. For coal, though, coal was formed similar fashion, but a little bit different. Coal is formed from plants that lived, millions and millions of years ago. Those plants, they died, again, covered with layers upon layers upon layers of water or dirt or other dead plants. And then again, the heat and pressure compresses them, and eventually we get coal from it all. Again, for extracting purposes, normally we're talking about mining here, right? So underground mines or tunneling mines, or we can do, I think it's called above ground mines where what is it called? Pit mining, where you have to dig a big hole, looks like a crater. You have to go in, extract it, and then you have to fill in the hole later. That's what we're talking about with coal. Here's kind of an interesting history of how we've used fossil fuels. So for most of human history, people have used small amounts of coal that they found close to the Earth's surface. But for the most part, right, coal, petroleum, natural gas, they mostly stayed underground. When people needed to, when people needed heat or light from combustion, they burned organic matter from Earth's ecosystem, mostly like your wood stoves, or animal fats were really popular, especially if you weren't living in an area that had lots of forests nearby. Then in England and Scotland in the 1700s, a couple of important things really happened. One of them was an energy crisis. So in England, forests were disappearing because people were using so much firewood to heat and light their homes. And so they were trying to figure out what's another way that they could keep their homes up and running. So that was one thing that was happening. The other thing was that they finally invented the steam engine. So steam engines did something that humans had not been able to do before. I want you to think into your history class. This is when we made that transition from using horses to fix our fields to motorized stuff. So we figured out a way that we could take heat energy from combustion and transform it into mechanical energy, or the ability to have things move around kind of for us. During the 1700s, the first steam engines powered pumps that moved water out of mines, and especially was important for helping us dig a little bit deeper into the earth to get some more coal that we could use to heat our homes. Now, fast forward about 100 years, during the 1800s, people figured out ways to use steam engines for other purposes, such as factories, or the picture here, the big locomotives and big steamships, think Titanic, right? And then other people invented other kinds of engines later on, such as the internal combustion engines that uses a petroleum product called gasoline, right? Electrical engines could convert electrical energy into motion, but the electrical energy had to come from somewhere, and that comes from burning coal or natural gas and converting that chemical energy into electrical energy. So today we are still using fossil fuels, right? We're heavily dependent on it. And something that we need to consider is just, what is happening to the carbon that is stored in fossil fuels? Where does that end up going? And even thinking about what about the energy within those fossil fuels? Where does that go? People take coal, petroleum, and natural gas out of the earth because we want the energy in those carbon to carbon, carbon hydrogen bonds. But think about it. That chemical energy was converted from sunlight through photosynthesis millions of years ago. This is like a very, very long term process that has been happening. Combustion of fossil fuels is super useful to us because of the energy transformations that it sets in motion, right? We're able to take chemical energy, turn it into heat energy, which can be turned into motion, electrical energy, and all these other kinds of energy, that we can form. As far as the matter part of it, though, as far as those individual carbon atoms, combustion of fossil fuels is a carbon flux. We talked about fluxes previously. Organic molecules in fossil fuels combine with oxygen to produce CO2 and H2O in water, right? And that all goes into the atmosphere. And we kind of already know what those long-term effects are of us constantly putting more carbon into the atmosphere. What your job now is to do the second half of this gizmo, which specifically looks at fossil fuels. Having this background information should make this next part flow just a little bit faster for you. If you have any questions, though, don't hesitate to ask.